Okay, so I'm hoping this will be a fairly simple video here quickly. One thing we haven't talked about is how to use your calculator in certain circumstances. So this is the sine of 305 degrees, and there's a degree mode we need to talk about. And this is the sine of 4 pi over 7, and that's in radians. There's a radian mode. So anytime you're doing trig, you do need to make sure you're in the right mode according to what the sine is, the sine of what you're looking for is in. So that's in degrees. So you would go to mode, and then there's a radian degree option. Now this is already in degrees, so if I just get out of that by hitting second mode to quit, and I just type in the sine of 305, it's reading that as degrees, and it's negative 0.8. It says to the nearest 10, so we'll say negative 0.8. If I was in radians, I'd get a totally different answer. So if I go to mode and switch that to radians, and if I happen to be in the wrong mode and then I type in the sine of 305, it's processing that as sine of 305 radians, which is a totally different answer. And you really won't know the difference because these decimals are usually pretty ugly. So you have to make sure you're in the right mode. So now that I went to mode and I went over and highlighted radians, now I am in radians, so for this one I can just type the sine of 4 pi divided by 7, and then close your parentheses. So that's what it'll take the sine of. We know we're in radians, and to the nearest tenth, it's not 0.9 because there's a 7, so that needs to get bumped up. That would actually be 1.0, technically to the nearest tenth. So knowing how to use your calculator is just a quick introductory thing there, and understanding the difference between the modes. For exercise 1, recall the following definitions of the sine and cosine functions. If theta is an angle drawn in standard position whose terminal ray passes through the point xy on the unit circle, this is telling us that the x-coordinate is r sine theta, and the y-coordinate, oops, I'm sorry, I did that backwards from what we did in class. X is r cosine theta, and y is r sine theta. So your sine theta, because we're in the unit circle, r is 1, so sine theta just equals y. And cosine theta, since r is 1, cosine theta just equals the x-coordinate. Just a little recall there. So in these exercises, we're really just reviewing basics, but now just in terms of trig. So f of 60 degrees. So if you want f of 60 degrees, you have to plug in 60 degrees for x. So f of 60 degrees will equal 6 times the sine of 60 degrees. And this is a value, anytime it's a 0, 30, 45, 60, or 90 angle, this value comes from your table. The 6 stays, and the sine of 60 is root 3 over 2. So this 6 technically being over 1, if you reduce the 6 with the 2, you get 3 over 1, which is 3 root 3, option 2. And the next one, if I'm doing g of 330, I'm plugging in a 330 degree angle to the g equation. So g of 330 equals 4 times the cosine of 330 minus 2 times the sine of 330. Now this one's a little bit tougher because 330 isn't in the first quadrant and as straightforward as 60 is. So when we go to evaluate this, we have our 4. With the cosine of 330, we have several things to consider. Number 1, what quadrant is in? So here's 0 to 180 to 270. Just shy of 360, we'll reach 330. So we know we're in quadrant 4, where the cosine will be a positive number, and the reference angle is 30. So the cosine of 30 is root 3 over 2. Minus 2 times the sine of 330. Sine in this quadrant is negative. I'm going to try to write that so it doesn't look like 2 minus. It's 2 times negative, and the sine of reference angle 30 is 1/2. So this portion, the 4 and the 2 will reduce to 2, and it will just be 2 root 3. And then negative 2 times negative 1/2 is a positive 1. Negative times negative gives you a positive. 2 times 1/2 gives you 1. Which of the following is not equal to 1? So these are a lot of your quadrantal angles. So I'm going to remind you of your sine. The sine of 0 is 0, so the sine of 180 is also 0. The sine of 90 is 1, so this is negative 1. So for our sine ones, the sine of 90 equals 1. The sine of 270 equals negative 1. And then for your cosine quadrantals, it starts at 1 and goes down to 0. So if this vertical pole is 0, then so is it down there. And if that's 1, then that's negative 1. So the cosine of 0-degree angle is 1. And the cosine of a 360-degree angle is also 1. So the only one that does not equal 1 is that guy. For an angle whose terminal ray lies in the third quadrant, I immediately stop, draw a terminal ray in the third quadrant. It is known that cosine is alpha, or cosine of alpha is negative 0.96. So if I were to draw that right triangle, there's my angle. I'll put that technically over 1. My adjacent is negative 0.96 over my hypotenuse, because cosine is adjacent over hypotenuse. So negative 0.96, and then if it's not a fraction, make it a fraction, put it over 1, and there's your hypotenuse. So we need the sine, which is opposite over hypotenuse. We can't find the opposite. We can call that our x-coordinate that we're looking for. So Pythagorean theorem, x squared plus negative 0.96 squared equals 1 squared. So if I do a negative 0.96, well, it's a negative number, so I got to keep it in parentheses. Negative 0.96 squared will give me 0.9216 equals 1, and then subtract 0.9216 over, so 1 minus 0.9216 will give me, so if I subtract that over, that'll give me x squared equals 0.0784, and then the square root of both sides gives me x equals plus or minus 0.28. Remember the plus or minus, and then make a logical decision. Is this a positive 0.28 or a negative? And you would be right if you said negative 0.28. And so your sine is your opposite over hypotenuse. Opposite, negative 0.28 over hypotenuse 1, and that is option 1. By the way, if you knew nothing about SOHCAHTOA and trig, but you just knew all students take calculus, quadrant 3, only tangent should be positive, so sine definitely has to be one of those negative answers. And then on the back, it's just a whole bunch of practice on coming up with these exact values again, like we did the other day. So in our first one, we first want to figure out the quadrant so we can determine plus or minus. So here's 0 degrees opening up to 180, and then 210 is going to be slightly past that. So it's a third quadrant angle in which only tangent is positive, so this will be negative. And then the reference angle is 30, and the sine of 30, which you need to memorize and know, 1/2. There's your answer. Sine of 210 is 1/2. Now, if you're in degrees, you can check some of these. Mode, degrees, sine of 210, negative 0.5. Okay, so you can check some of these. So these will be all pretty straightforward. Just in F, a negative 60 degrees means just we're opening up backwards. So negative 60 puts us there. So because we're in the fourth quadrant and only cosine is positive there, this is going to be a negative answer. And then the reference angle, of course, is 60. So the sine of 60 is from your table, √3/2. That one would be a tougher one to check on your calculator because the sine of negative 60 is going to give you a very ugly number. Now, if it was open response, it would be tough to figure out what that radical is. That's why you need to know your values. But as far as like a multiple choice, if that's what you got and you wanted to check this choice of negative root 3 over 2, you will see the same decimal. And then in the bottom, we're all in radians. So these are typically tougher because we can kind of position degrees pretty easily. But radians we struggle a little bit more with, starting with the 3 pi over 2. That one's not terrible. Hopefully you're getting used to 0, pi, pi over 2. So 0, 1 pi over 2, 2 pi over 2, 3 pi over 2. And then back to 4 pi over 2 slash 2 pi. And the cosine of 0 is 1, and the cosine of this is down to 0. So if that's 1, this is a negative 1 value, and if that's a 0 value, this is a 0 value. So the cosine of 3 pi over 2 is just 0. It has a reference angle. If you drew that terminal ray and thought of it this way, it has a reference angle of 90, and from your table, the cosine of 90 is 0, so you would just go with 0. Okay? Sine of pi over 2, I would think sine of 0 is 0, sine of 180 is 0, sine of pi over 2, therefore, is 1, and this is negative 1, so this just is 1. That's directly from your table, so you don't have to do much thinking there. But then, with radians, again, with this denominator idea, and kind of trying to figure out where 3 pi over 4 is. It's not as easy as degrees. So 0 radians, and this is pi radians. So because our denominator is 4, we make that 4 pi over 4. That means 3 pi over 4 is here. So we're a second quadrant angle, and is cosine supposed to be positive or negative in quadrant 2? Sine is positive, so cosine is negative, and your reference angle from 3 pi over 4 to 4 pi over 4 is pi over 4. So again, from your table, the cosine of pi over 4, if you are getting more fluent at this, that's the same as the cosine of 45, and that answer is root 2 over 2, so that gives you negative root 2 over 2. Sine of pi over 3 is straight from your, that's a first quadrant angle, so that's straight from your table. Pi over 3 is like 60 degrees, so sine of 60, root 3 over 2. If anyone's bored and wants to go back and check how many times my pencil lead has broken in this video, I'd love to know, because I feel like it's been 100. Cosine of 7 pi over 6. So, denominator is 6. So we will label this, just as a point of reference, 6 pi over 6. So 7 pi over 6 is here. So where all students take, we're a third quadrant angle, where only tangent should be positive. Since we're taking the cosine, that's a negative answer. The reference angle from 6 pi over 6 to 7 pi over 6 is 1 pi over 6. So the cosine of 1 pi over 6 from your table is root 3 over 2. So that gives you the numerical portion. And lastly, a radian one going backwards. So 0, and just for a frame of reference, with a denominator of 3, labeled as negative 3 pi over 3. So negative 2 pi over 3 would be here-ish. Okay, so we are a third quadrant angle. Only tangent should be positive, so sine should be negative. And the reference angle from negative 2 pi over 3 to negative 3 pi over 3 is pi over 3. The sine of pi over 3 is the same as the sine of 60 degrees, which is root 3 over 2. Okay? So if you really memorize your table mostly in degrees, I'm okay with that, but you need to be very fluent with the fact that pi over 2 is 90, pi over 3, remember pi is just 180, so pi over 3 is 60. Pi over 4 is 45, and pi over 6 is 30. So if you do go and change reference angles mentally, pi over 3 is the same as 60 degrees, and you just know your sine or your cosine or your tangent of 60, that can happen pretty fluently, so you can make that transition within a millisecond, hopefully. But that's the video. Nothing new, really. this is function notation, which is old news. We've done function notation. We've done evaluating trig values, like evaluating what 6 times the sine of 68. It's just kind of combining those two topics, so it shouldn't be too much of a stretch. And it really just reinforces stuff that we've been doing. So the homework that you are to do is this one that I handed out on Friday, more work with sine and cosine functions.